Yeah, students, now we are going to do some of the numericals based on the relative velocity. Last time we did the numericals of two bodies going in the same direction, maybe A and B, and the bodies going in the opposite direction, also we saw. Now today we are going to see two bodies. One is going in this direction, another is going in the other direction. Then what will happen is the relative velocity will be taken along the diagonal here. So I would like to take a little more time to explain this one. This is a parallelogram law of vectors where the final resultant will be in this one, but in relative velocity it will not be like this. Suppose this is VA and this is VB, and there's an angle here in between. So usually what happens is you will superimpose equal and opposite velocity of VA on this one minus VA, and that is done so that VA is brought to rest. The body A is brought to rest. So one time you impose equal and opposite velocity in this one. At the same time you need to impose the same velocity in VB also. So that means it will come in the same direction. It will come in the same direction for both VA and VB. So as it has become minus VA here, now we need to find out the resultant in between this. The resultant will be coming in between this. So you will find this will be the value here. So this will be called as VAB. So that's what we already saw this one. This is going to be 180 minus theta, and this is going to be beta. This is everything we have already seen in the previous classes. So we're going to base few numericals based on two different angles, like two velocities in different angles. So we'll go ahead and try to find out some of the numericals. So let us do numerical number 55. A compass of an aeroplane indicates that it is heading due north, and its airspeed indicator shows that it is moving relative to the airspeed of 120 km per hour. If there is a wind blowing from west to east at a speed of 50 km per hour with respect to Earth, then find the velocity of the airplane relative to the Earth. So this is quite a simple question which is asked. So we'll try to find out how we need to get this answer. First of all, we'll make that diagram for this. So the airplane is heading toward this direction. This is VA, and it is going towards northern direction. And interestingly, there is a wind is also blowing towards this direction here. So it is showing here, if there is a wind blowing from west to east, this is eastern direction. So this is VW. So the wind is blowing in this direction here. Now what is the velocity of the wind? It is given here as 50 km per hour. And here this is going to be 120 km per hour. That's already given here. Now what will be the final outcome, where the thing will go? Now we need to find out that. Find the velocity of the airplane relative to the Earth, how it will head on. Definitely you will see the airplane heading on towards this direction because the wind is pushing this one simultaneously. It will not be able to go straight. It will be finally landing up in this direction here, that is V. So you will see them. It is going to have an alpha angle which is going to be changed. Now what is the velocity of V here? So write down first of all, velocity of the airplane is 120 km per hour, and velocity of the wind is equal to 50 km per hour. And what is V? So you can see this one, it is in terms of the rectangular component of vectors. So V is going to be equal to under root of VA square plus VW square. Add both is 1. Under root of 120 square plus 50 square. When you do this one, you will get the final answer as 130 kilometers per hour you will get. That is the velocity of this one. And you can find out the angle also in which it will take. The angle it will be taken here. It's also you can take, it will find out that is going to be tan alpha is going to be equal to, what is tan alpha? That's going to be equal to VW upon VA. That is opposite upon perpendicular. So it is opposite upon adjacent side. So you get here as 50 upon 120. You can cancel this 2 and you will get here as tan alpha is equal to 5 by 12. So that will be the angle you can calculate. Now we'll see the second part of the question here. In what direction should the pilot steer the plane through the air in order to travel due north? Anyhow, this guy has to head on towards this direction. Wind is blowing, fine, but he has to head on towards the northern direction. So the pilot can negotiate into some other direction so that he can finally land up in the destination over here. The destination is here. He cannot go on to some other place. So in what direction he has to steer the plane so that he could land up here? So what is the common sense says? When the wind is blowing so much in the side, so you take this direction, in this direction you take the aeroplane, and simultaneously you will be able to land up here. So you can find out some route where you got to take in this direction so that you can be there in this place. So the second part of the question, so this is the first part of the question here. The second part of the question says, right, let's go ahead and draw this diagram here. In what direction should the pilot steer the plane? Through the air in order to travel due north. So wind is traveling in this direction, VW. Now finally he should go in this direction. This should be the final velocity. V should be this velocity. Now if V should be the final velocity over here, now let us try to get this wind into rest. Put the wind finally into rest. So we are going to put equal and opposite velocity of minus VW here. That is for one time. And the next time is, if there could be a resultant, this could be a resultant, you will be able to see here it will be the value here. Here it will be the value here. So this has been put twice. So here it gets cancelled out. It needs to be put one more time here as minus the VW. So that one time it gets cancelled, and this one you will get the final value as VA here. This is the direction you need to negotiate. Same direction here. Now here it is going to be 50 kilometers per hour. That's a wind velocity of the wind. And as well as now we need to see how much should be this velocity here so that you will be able to get this value. So in other words, we need not even calculate this way. We can see the resultant coming here itself. Whereas VW is the velocity of the wind, which is 50 kilometers per hour. And VA is the velocity of the aeroplane, which is already given as 120 kilometers per hour. So when he strikes in this direction, automatically this will be resultant. The resultant goes here, and he is anyhow heading on towards the northern direction then only. So V we can calculate here. So VA and VW, and you get a parallelogram law of vectors. This is going to be the resultant here. So seeking this kind of a issue, now we need to find out the value of theta here. So you get here sine theta is going to be equal to, what is sine theta? Sine theta is going to be equal to, it is going to be opposite upon hypotenuse. So it becomes 50 upon 120. So you cancel this one. So sine theta is going to be equal to 5 by 12. So you get here theta is going to be equal to sine inverse of 5 by 12. That will be the angle in which it will be there. And also, what then will be the velocity of the plane relative to the earth? What will be the velocity here relative to the earth? So we need to find out. You want to find out v here is equal to under root of va square minus vw square. So it becomes equal to under root of 120 square minus 50 square, and v is going to be equal to 109 kilometers per hour will be the velocity, final velocity in which it will be heading on this direction. So you get this one and this angle also. Now we'll go to the next question, question number 56. It's also a very simple question. A rain is falling vertically with a speed of 30 meter per second. So you find the rain is falling vertically with a speed of 30 meter per second. A woman on a bicycle is traveling with a speed of 10 meter per second in north to south direction. So 10 meter per second in north to south direction. So she is heading from north towards south. So she is going in this direction here. So this is the velocity of the woman here. This is the velocity of the rain here, which is coming down. Now, in what direction should she hold her umbrella in order to protect herself from the rain? So rain is coming down like this. Now what direction she will hold the umbrella? So first of all, this v, the velocity of the woman, try to put the velocity of the woman into rest. Put the velocity of her into rest, so imposing equal and opposite velocity of her for both the women as well as the rain. So this one will give you cancel out, it will become 0. So we need to impose one more time for the rain. So we impose one more time for the rain also. One is already got cancelled. So you got only two things now. This is the velocity of the women and this is the velocity of the rain. So this is the velocity here of the rain VR. If these two is there, then what will happen here is there will be a position here where you need to see. This will be the way in which you will be able to get the resultant here. This is 30 here and she is already heading on with the 10 here, 10 meter per second. This is 10 meter per second. So 30, this is 30 here, 30 meter per second, 10 meter per second. Now we can find out the angle which is here. In simultaneously, you can see this one, it will coming like this, and vertically in opposite angle is called, this is theta. So the umbrella will be like this. This should be her umbrella. Umbrella should be in this direction with an angle theta to the perpendicular. How did you find out? Because we found out by the angle of theta here. So going further down, how to get this angle here? We can get it by tan theta is going to be equal to. So as usual, you can write the first line, velocity of the women is going to be equal to 10 meter per second. Velocity of the rain is equal to 30 meter per second. These are all things which is given here. And tan theta is going to be velocity of the women upon velocity of the rain, because tan theta is going to be equal to this distance, that is called velocity of the women upon the perpendicular. So it is going to be opposite upon perpendicular. So you get this one, and tan theta is going to be equal to what is velocity of the women? 10 upon the velocity of the rain is 30. So tan theta is equal to 1 by 3. Theta is going to be equal to tan inverse of 1 by 3. So this is the value. With what speed does the rain strike the umbrella? If this is the value of theta here, how much speed you will get the hit here? So that you can calculate using the relation of v is going to be equal to under root of vr square plus vw square, the rain square as well as the velocity of the women whole square. Under root of, it is 30 square plus 10 square. It is going to be equal to 900 plus 100. So it is going to be equal to 1000 under root, which will simultaneously become equal to 31.6 meter per second. So that will be the velocity in which it will be hitting. Hitting will be more because you are already traveling. That's the reason whenever you are traveling in a higher speed, you will feel the rain is hitting you so far much. Rain is actually coming in 30 only, but look at the way it is hitting here. It is 31.6 it is hitting. Even though she is going in only 10 meter per second, if you go in a higher speed, the more the speed you take, the more heavy the rain will be for you. Even though the rain is not actually so heavy, according to the relative velocity principle, you will receive a heavy rain because you are going in a higher speed. So it is advisable whenever it rains, don't go in a high speed. Lower your speed. You will be able to experience it is much lesser intensity of the velocity you will receive. Alright, we'll go to the next question now. Now let us read this question number 57. A man can swim with a speed of 4 km per hour in a still water. There is his maximum speed for him. How long does he take to cross a river 1 km wide if the river flows steadily at 3 km per hour and he takes his stroke normal to the river current? How far down the river does he go when he reaches the other bank? So it's a very typical question where there is a flow of river with a speed of 3 km per hour and a man is perpendicularly, he is heading on towards the next bank. So we can draw a diagram like this. So the diagram can be like this, where the river is going in this direction or the river is moving in this direction here. This is the velocity of the waters and this guy is heading straight in this direction. This is the way in which he wanted to head on. But eventually he will not reach here, he will be reaching here in this place Q. He will be displaced because the waters will take him to the other side. So this should be the final relative velocity where he will end up here in this place. Now you can write down the facts which is given here. The fact which is given here is what is the velocity of the man and what is the velocity of the waters. So velocity of man is equal to Vm is equal to, we already know it is 4 kilometers per hour, and velocity of the waters is going to be equal to 3 kilometers per hour. Now he is going to head on towards the next direction like this. But it is asked, the question is asked is, the question it says, how long does he take to cross a river? Time taken to cross the river. So he's heading on in this direction here. He's heading on here like this, and the river is 1 kilometer wide. It is already given here as 1 kilometer. The question says it is 1 kilometer here. If this is 1 kilometer here, we can easily find out using this way itself. Time taken is going to be equal to distance upon velocity. So time taken is equal to 1 kilometer. This is perpendicular is 1 kilometer, and the same perpendicular velocity we can find out. We can put this one, the same thing itself we can put, that is going to be equal to 4 kilometers per hour. These two get cancelled out. So time is equal to 1 by 4 hour he will take. That's the time he will take. The next part of the question, it says, how far does he go? What is this distance he goes in this time? Now look at this one. When he travels here from here to here, he will take 15 minutes. Within 15 minutes he will be there. That 15 minutes he is being pushed by this velocity. This velocity is pushing him for all that 15 minutes. So 15 minutes he takes from this side to this side. Actually he will be heading on towards this direction, but we can take this component of the velocity multiplied by the time. Then you will get this PQ. So if you want to get PQ here, PQ, the distance the distance PQ is equal to velocity of the waters into time. Velocity of the water at this side is going to be equal to 3 kilometers per hour into time is 1 by 4 hour. So hour and hour gets cancelled out. Now this is going to be 3 by 4 kilometers. So it is going to be equal to 3 by 4 kilometer. It is 750 meters then. This is PQ. 750 meters you will see. So this is going to be equal to 750 meters. Alright, we'll go to the next question now. The question number 58, it says, in a harbor, wind is blowing at a speed of 72 kilometers per hour, and the flag on the mast of a boat anchored in the harbor flutters along northeast direction. So look at this one. There is a boat which is staying here, and this boat is having a kind of pole or something, and in that pole the flag flutters. The flag is fluttering. The flag is fluttering in this direction. You're able to see the flag is fluttering in this direction. That is called northeast direction. So you find here, this is north and this is east, exactly 45 degrees northeast direction. The flag is fluttering. That means if the flag is moving in this direction, the stationary boat, the boat is just stationary here. The flag is going in this direction means which direction the wind is blowing? The wind is blowing in this direction here. This is the wind direction. That's the reason the flag is moving in this direction. The flag is just fluttering in this direction. Now the thing happens is, the flag is going in the direction with the 72 kilometers per hour is a wind speed. As it happens, if the boat starts moving at a speed of 51 kilometers per hour towards north, now the boat is already moving here down. The velocity of the boat is going to be equal to 51 kilometers per hour. The boat is heading in this direction, wind is moving in this direction. What is the direction of the flag on the mast of the boat? So can you just imagine how it will happen? What will be the thing? It is heading in this direction and wind is going in this direction. So the flag will not flutter like this. The flag will start fluttering in this direction maybe. The flag will be fluttering in this direction because boat is already heading in this direction. So the first part in this one, when we want to make the diagram properly, is put the boat into rest by imposing opposite velocity here minus VB on both the boat and the wind. So this is the velocity of the wind here, velocity of the wind here, velocity of the boat here. So one time we have put here for this one, another time you need to put for this one also minus VB, so that both will be taking into rest. Here it is getting into rest, and the second one minus VB, and this one will be able to have the final value here. So it will almost sort of give you kind of maybe somewhere here we'll be able to see the velocity of the wind and the boat together. You will feel the final velocity coming in this direction here. I'm again explaining here. The first instance is boat is at rest, wind is only moving, so the flag flutters like this. When the flag is fluttering like this, all of a sudden the boat is heading on towards this direction with a speed of 51 kilometers per hour. When the boat is heading on this direction, what direction will the flag now flutter? So what we need to do, impose equal and opposite velocity of the boat here, once for the boat, next one for the wind also. So the boat velocity gets cancelled out. So this one velocity of the wind and the second velocity of minus VB, these two will give the final resultant here as the velocity of the wind with respect to the boat. Here this will be the resultant velocity of the flag. Now we need to find out this value. This one also you can find out, right? So let us write this value here. The velocity of the boat is going to be equal to 51 kilometers per hour. Velocity of the wind is equal to 72 kilometers per hour. Now we need to find out the angle in which it is going to be happening. Here this angle, theta angle, is going to be 45 degrees. Now we need to find out beta here. Beta we need to find out. Now we have already studied in the relative velocity formula, tan beta we have found out as VB sine 180 minus theta upon VW plus VB cos 180 minus theta. We have already studied this formula. So what is VB? VB is going to be equal to the velocity of the boat. It is 51 into sine 180 minus 45. So it is going to be sine 135 degrees upon VW 72 plus 51 cos 135 degrees. Now we need to put the values here. So once you put the values, then you will get the rest of the answer here. So what will happen here is 51 plus sine 135 is going to be equal to 1 by under root 2. It will be exactly the same as that of sine 45 itself. Sine 45 is equal to sine 135 is equal to, what is the value? 1 by under root 2 divided by 72. Here cos is going to be equal to minus value you will get. 51 1 by under root 2 you will get. Minus of. Because cos 135 will give minus half. Minus 1 by under root 2. So putting this value here, you will get here as approximately equal to 36 upon 36 you will get, that will become equal to 1. So that is tan beta. Tan beta finally will become equal to 1. So tan beta equal to 1. So what is beta is going to be equal to? So beta is going to be equal to 45 degrees will be the final answer. What is tan beta? Here again 45 degrees will be there. It is almost close to the same place. You will get this final resultant. Though it has been shown like this, but theta and beta will almost coincide and it will be exactly in the same eastern direction. The flag will flutter. So that's the direction. It is just only direction is asked this. They are not asking what is the velocity here. It will be fluttering. They just ask the velocity. So we'll click on to only the direction formula, and then we got the value as 45 degrees. Alright children, thank you. I'll be giving you a worksheet also to solve some of the questions. So we have seen all the three varieties. We have seen the varieties of when the two velocities are in the same direction, when two velocities are in the opposite direction, and the velocity is there in the two different directions. So we have seen all of them, and you will be getting some numericals based on all the three cases. Try to solve them and try to send it also. Thank you.